Welcome back to the second part of operation and working of an MCB. If you have not watched the part 1 video, please do watch that video for better understanding and come back to this video. The link to the part 1 video is in the description box. In my part 1 video, I have explained you the working of an MCB in a simple form. Now let's see how actually an MCB works internally. This is the cross-sectional view or the internal view of an MCB. Let's first understand the past, then let's focus on the working of this MCB. This is the input terminal. You have an electromagnet. This is the electromagnet. This is the knob. You push this knob up to on this MCB. You have the output terminal. This is the bimetallic strip which I have explained you in my part 1 video, and this is the moving contact. You have fixed contact, and this is our chute. Okay. Now you have understood the part, so let's quickly focus the current flow in this MCB. Focus on the red cursor for the flow of current path. You will connect the input or the source to the input terminal. You connect the source to the input terminal. From the input terminal, the currents come till here. It will pass through these windings and waits at this fixed contact. Once you push this knob upwards and once this MCB is on, then this moving contacts come in contact with the fixed contact so that current flows from this fixed contact to the moving contact. From the moving contact, it goes to the bimetallic strip, and from the bimetallic strip, it comes back to the output terminal, and from the output terminal, you will connect your load. Okay, this is the actual flow of the current in this MCB. Now, if you clearly observe, we are using an electromagnet and a bimetallic strip in between the flow of the current path, because we are using these two for the safety of our load. So, first, with the help of electromagnet, we are providing safety to our load for short circuit faults, and with the help of bimetallic strip, we are providing safety to overload faults. If you clearly see, when you're turning on this MCB or pushing it upward, this will move down, right? This will move down so that this moving contact can come in contact to the fixed contact. Okay, now let's see how this electromagnet and bimetallic strips help disconnect the load with the source in a faulty condition. So assume your load is a motor and it's taking 5 amps of current. Okay, and the rating of this MCB is 8 amps. So remember very carefully, your bimetallic strip is protecting you from overload. So this particular example is for overload situation, and your bimetallic strip helps your load to disconnect from the source in this overload condition. Let's see how this bimetallic strip disconnects the load. When your source is connected and your load is connected, your load starts drawing current, and the current flows in this path. The moving contact will close. Your current flows from the fixed contact to moving contact. It passes through the bimetallic strip and it's come back to the load. Till now, there is no objection to the current flow. If you have increased the load on this motor, now this motor started taking, instead of 5 amps, it's taking 9 amps of current. So it is taking more than rating of your MCB. Your load is demanding 9 amps of current. So your source should start sending 9 amps of current. Your source will start sending 9 amps of current. It flows through this electromagnet and from the fixed contact to the moving contact, and it passes through this bimetallic strip. When this 9 amps of current passes through this bimetallic strip, your bimetallic strip is designed only for 8 amps of current. When this current increases above 8 amps, your bimetallic strip starts to bend. From here, the current is flowing, right? Your bimetallic strip starts to bend. This will bend. When this will bend here, see, if you push this contact up, this will come down, right? So this point will come and stick to your bimetallic strip, right? When this bimetallic strip bends over here, so this part will come up so that it will push this metal object. You can see this metal object, right? It will push this metal object up. When this metal object is pushed up, this will automatically come down, because here is a spring which is loaded, and when this is pushed up, the spring will expand and this will come down, and your moving contact and fixed contact are separated. So your load is saved from your source side when there is an overload condition. I hope you have understood the overload condition. Let me quickly clear this up so that I could explain you the short circuit condition. Okay, as I've told you before, MCB protects us from two cases. One is overload condition and one is short circuit conditions. We have seen the overload condition and our bimetallic strip is serving the overload condition. Let's see our short circuit condition. And short circuit is protected with the help of this electromagnet. Let's see how this electromagnet saves our load from the short circuit condition. Your source is connected to the input terminal and your load is connected over here. Assume this load is also a motor and this motor is taking some 5 amps and the standard rating of this is 8 amps. Assume it, okay? I'm taking a random value, so just assume it. When your source is connected, the same old procedure, your current passes through this winding, that is electromagnet. From this electromagnet, it comes to the fixed contact. When you push this knob up, this moving contact comes in contact with the fixed contact. So current flows from the fixed contact to the moving contact. From the bimetallic strip, it goes to the output and it connects to the load. Okay, this is your actual current flow in this MCB. Now let's see, due to some fault, your motor or your load got short circuited. When there is a short circuit, your load starts taking high amount of current. So this high amount of currents are very dangerous to this load. So to protect this, we use short circuit protection. Short circuit protection is given with electromagnet. So let's see how this electromagnet gives the short circuit protection. As soon as you push this knob up, this fixed contact and moving contact get in contact with each other. But this point, this particular point comes in contact with this point, right? When this is moving this way, this point will come in contact with this point. This is here. You have an electromagnet and inside an electromagnet you have a plunger. This is a plunger and you have a spring inside this. There is a spring and a plunger over here and you have some rating for this electromagnet. As soon as there is a short circuit fault, there is a high flow of current in this MCB and due to high flow of current, this electromagnet gets magnetized. Before also due to current, this electromagnet gets magnetized, but this spring is in such a form that till that particular time this electromagnet does not create any effect on the spring. As soon as high amount of current goes through this electromagnet gets more magnetized and this more magnetized electromagnet starts pushing this plunger upward. Okay, the spring gets released and this plunger is pushed up so that it creates a small pressure over here and your knob moves backward and your load is saved from the source. By this you can understand that MCB protects us from the overload as well as protects us from the short circuit condition. And short circuit protection is given with the help of electromagnet and overload protection is given with the help of bimetallic strip. I hope you're clear up till this point. Few of you might have some doubts like why are we using bimetallic strip only for overload conditions and why electromagnet is used only for short circuit condition. Why can't we interchange them? You might have such questions, right? I'll definitely explain you in the part 3 video, so stay tuned for the part 3 video. That's all for today's video. I hope you have understood it. Like this video, please do like, share, subscribe my channel. This is Sandeep Shaktri signing off.